You know, it's funny. We spend thousands on the latest GPUs, these huge, beautiful monitors.
Right.
And then we connect them with whatever cheap wire we can find in a drawer.
It's the classic bottleneck, isn't it?
Yeah.
The engine of a Ferrari with the tires of a bicycle.
Exactly. So today we're looking at why that standard copper fails you when you really start pushing the limits.
And the optical hardware you need to fix it.
So for our deep dive, we're looking at the NTI DP8K-FO-10M-MMLC.
That's a mouthful.
It is.
Mm-hmm.
It's a DisplayPort 1.4 active optical cable, and our mission is really to figure out how this thing pushes a full 8K signal across a room.
Without needing a separate power brick. That's the key.
That's the magic. So let's just jump into the specs first. We are dealing with 32.4 gigabits per second of bandwidth here.
Which is exactly what you need for, full 8K at 60 hertz.
Mm-hmm.
Or, for gamers, high frame rate 4K at 120 hertz.
A standard cable just chokes on that.
Completely, it can't handle it.
And usually when you get into these active cables to handle that kind of load, you have to deal with those annoying USB dongles for power.
Yeah, to power the chips inside. But this one,
it's different. It doesn't have them.
oh, well, that's the smart part. It's a hybrid cable. It uses fiber optics for the video data, but it keeps copper cores inside too.
Okay, and the copper is 4.
It's there specifically to steal just enough power from the DisplayPort source itself. So no external bricks needed. It's just plug and play.
That's a huge deal for clean setups. Now, this specific model is 10 meters long, so about 32 feet.
Mm-hmm.
If I tried to run a normal copper cable that far at 8K,
Mm-hmm.
what would actually happen?
Well, you run into physics. Copper suffers from what's called attenuation. At those high frequencies, the electrical resistance of the wire itself it kills the signal.
So you get glitches.
You get digital snow, sparkles on the screen, or more likely it just goes black, nothing gets through.
But because this is using light for the actual video signal?
Resistance isn't a factor. The photons just shoot straight through. I mean, this technology scales up to 100 meters with zero signal loss.
And that optical nature brings up another huge benefit that was in the sources. Noise immunity.
Oh, this is critical.
Yeah.
Fiber is totally immune to radio frequency and electromagnetic interference, RFI and EMI.
So if you're in, say, a server room or a factory floor with a ton of electrical noise,
A copper cable basically acts like an antenna for all that static. A fiber cable just doesn't care. It's completely isolated.
and that's not just for messy server rooms. The documentation brought up use cases where a glitch isn't just annoying, it could be dangerous. It mentioned medical imaging.
Right. Think about it. If a surgeon is relying on an 8K display for a really precise procedure, you cannot afford a dropped frame or a single artifact.
Reliability becomes a safety issue.
Absolutely.
They also listed airplane onboard video systems. I assume that's about durability. The specs say it operates from -40 all the way to 158 degrees Fahrenheit.
The temperature range is part of it, sure. It can handle an unpressurized cargo hold. But in aerospace, it's also about weight.
Lighter than copper.
Significantly lighter than thick, shielded copper cables. And when you're wiring an entire plane, all those pounds add up to fuel costs.
That makes perfect sense. Okay, so there is one little catch with these hybrid cables, right? The thing that trips people up.
Yes. They're directional.
You can't just plug either end in wherever.
Spot on. The connectors are labeled source and display. And if you pull 30 feet of this cable through a tight wall conduit and then realize the source end is sitting next to your monitor,
Oh, no.
you're starting all over again.
That sounds like an absolute nightmare. Now let's talk price. This 10-meter cable is listed at $175. That is steep.
It's a fair point. You can buy a whole secondary monitor for that.
So is the active tech really justifying that kind of markup?
You have to view it as a professional component. It's not really a consumer accessory. It's TAA compliant, it's ruggedized, and it guarantees that 32.4 GBPs over a distance where a $20 cable would fail instantly.
So it's infrastructure.
It's infrastructure, exactly.
Yeah. It's the buy nice or buy twice rule, except in this case, it's buy this or it just won't work.
Precisely. It fills that gap where physics just makes copper impossible.
So to wrap this up, the NTI DP8K is the solution for when you need to move massive bandwidth over a long distance and you need it to be clean.
It's hybrid, it's tough, and it uses light to do the heavy lifting. It's really the standard for the next generation of displays.
It does make you wonder, though. We're clearly hitting the physical limits of copper. In, 10 years? Do you think we'll even be using metal wires for high-end video at all?
I doubt it. At a certain point, electrons just can't keep up with photons.
Thanks for diving in with us. We'll catch you on the next one.